These next few problems are transformations, and transformations include going up and down and back and forth, but it's mostly talking about stretches and shrinks. And we're just doing vertical ones, we're not doing horizontal ones. So this says, describe the transformation of f represented by g, then graph each function. So here we have x to the fourth again. And what is happening here? We've got two things happening here. We have a vertical stretch by a factor of, oh, see, look, I just made a mistake. It's not a stretch, it's a shrink. A vertical shrink by 1/4. And that negative tells us that we have a reflection over the x-axis. Okay, so we did x to the fourth before, kind of looks like this. And this one, okay, when we graph this one, it's going to go out a little ways because when it's stretching, it opens up a little bit more and it's being flipped over. So for this one I actually did a table.
Any teachers left in the building? The district has left some mandarin oranges down here for you. If you'd like to come grab some before you leave for the weekend.
Mandarin oranges, yay! That just made my whole weekend. Okay, so for this one, I actually plotted points. I've got -2, -1, 0, 1, 2. That actually really is nice for the district to do that. I'm not being grateful. So anyway, that is nice. Okay, sorry. So when I plug in -2 into this equation, I get -4. This is -1/4. This of course is 0. Then I have -1/4 again, and I have -4. Yeah. Okay, so when we plot these points, I have -2, -4. 1, 2, 3, 4. I have 1, -1, -1/4. Then 0. And then it's basically the same thing on the other side. All right, so this one you can see opened up a little tiny bit more. And it's flipped over the x-axis. In a lot of these, you can use Desmos if you want. You put that in and there's a way that you can look up the table so that you don't have to crunch these numbers. You can also, if you have a graphing calculator, you can also put it in your graphing calculator. And if you don't know how to do that, you can ask me and I'll let you know. But it's a lot easier than putting all these in and crunching them all out. All right, so now I would like you to try this one. Okay, so we've got a couple things going on here. We start with our x cubed, and we have a vertical stretch this time. Vertical stretch by a factor of 4. And we also have it moving to the left, 2. Okay, so to the left, 2. All right, so remember our x cubed, again, looks something like this. Okay, and now it's going to stretch by 4, which means it's going to close up more. If we're multiplying it by 4, those values are going to get big really quick. I also did a table for this one also. And so we have, I started at -4, -3, -2, -1, and then I have 0 also. At -4, this is -32, so that isn't even going to fit on there. -3 is -4, -2 is 0, -1 is 4, and 0, of course, is, well, big, 32. All right, so -3, -4, 1, 2, 3, 1, 2, 3, 4, -2, 0, -1, 4, 4, and then it gets really, really big. So it actually straightens out a little bit for this one. Again, put it in Desmos if you didn't want to crunch the numbers. All right, writing transformed polynomials. All right, f of x equals this function right here. Write a rule for g, that means we're writing where the new location, and then graph each function. Describe the graph of g as a transformation of the graph of f. So what's happening is, I'm starting one place and they want me to do this to this function right here. So I'm going to plug in -x for every x value. All right, well, -x, let me write it here, -x times -x times -x is -x to the third. Now, if I just have two of them, I'm going to have a positive and then +1. So here is g of x. This is f of x. So what happened? This is where I started. This is where I ended up. What does this mean? This means that I had a reflection over the y-axis. Okay, and in this case, I did use Desmos. I cheated a little bit. Okay, it looks like this. And then when it's flipped over, so it's like this, when it's flipped over the y-axis, it looks like that. You could really have some fun doing art with this kind of stuff, I think. Remember that Batman thing I showed you and somebody had written out the equations for that? Anyway, I think it's really cool. Okay, so here's one for you to try. It's the same thing. Okay, write a rule for g and then graph each function. Describe the graph of g as a transformation of the graph of f. So this time, they want you to multiply everything through by 3. So we're going to do 3 times x cubed plus x squared plus 1. So this is 3x cubed plus 3x squared plus 3. Okay, and again, I'm going to do it on Desmos. But what's happening here, okay, that should look familiar. What's happening here is a vertical stretch by a factor of 3. So here again is that same one. This is the same one we did before. And this is what it looks like when you, okay, the blue one is the original. I know it was red. It was red. Oh no, I'm sorry. The red one is still the original. And the blue one just becomes a little bit more loopy, I guess. And you can see how it gets smaller faster, it gets bigger faster. That's what that 3 is doing. It's making those values bigger quicker. Okay, I'm gonna finish up on, I think there's only one video left, on the next video.